Okay, in our series of lectures on processor scheduling, we have discussed what sort of schedulings are required for the processes. We say okay, once we are to execute a process, it requires some sort of a resources. We just discuss what sort of a resources are required for a process. Then we discuss about what sort of a states are there for the processes. Maybe it has got a new state, it has got different states there. Now, each of the process, as we said, it goes from one state to the others. Now, what we are to say is, once we have got a processes which we have got, then we have discussed about how exactly we can schedule them. By scheduling, we mean how exactly one process will be coming after the another process. Maybe today we will just discuss about process synchronization. What we mean by synchronization is, in case I have got a number of processes which are there, then how exactly they can execute. Now, that is what we say, we will be discussing about cooperative processes, then what sort of a problems arise once a cooperative process has to execute, maybe that is what we call as the critical section problems. Then we will discuss about how exactly those sort of things can be synchronized, and maybe at a later stage we will discuss some aspect of the semaphores there. Now, we say cooperative processes, as we say there is types of processes. One we say independent process, that is a process which does not get affected by the execution of the other process. What we say is let us say there are two processes P 1 and P 2, they are independent of each other, then we say they are being executed at their own times. So, maybe they are executing at the asynchronous fashion, or we have got a cooperative processes, that is processes which can be affected or affected by the execution of other processes. Let us say we say we have got a process A, let us say we have got another process B. Now, let us say these are the two processes which are executing. Now, since there is no commonality between these processes, we call them as independent processes. Now, let us say for this process A, there are process B and process C, which may be their child processes there. Now, what happens is, let us say the moment one process A is executing, B or C may not be there, but afterwards what happens is this process A gives rise to process B as well as process C. Now, as we discussed in our earlier sessions, these processes may be executed independent of each other, that is this process B starts, this goes into the suspended state, or they can be executed at the same time. Now, this is what we say, once we say they are to be executed at the same time, then maybe this process will require some sort of a resources which are available with this, or this process may require some resources which are available with this, or there may be some variables which are common with the process B and which are there with the process A itself. Now, these are the processes which we say they will be executed in a cooperative way. Whereas, if I look at this process A and B, they will be depending independently, whereas this process will be executed in a cooperative way. So, this is what we call as the cooperative processes, that is the process which is affected by the execution of the other process there. Now, what sort of advantages are there in case we run a processes in the cooperative mode? Maybe I am going for the information sharing. Let us say I have got a variable which is there in a process A, then maybe same variable can be shared with the other variable also. Now, it can give you the computational speed up. Let us say one process is executing on one processor, maybe the other process is executing on the other processor there. So, what will happen? Maybe two processes are executing at the same time, this will give you the computational speed up. Maybe I can think about designing my software in such a way that they become the modular in nature. Modular in the sense that I can think about designing a processes which is a module which is working independent entity there, or it helps me in running the process in a convenient way. So, these are some of the advantages which are there in case of the cooperative processes. Now, once we say there is a process, let us say this process is there and they are running in a cooperative way, there may be some sort of a communication which may be taking place between these processes A and B. Now, what sort of a communication can be there? It can be the process may be sending some message to the other process. Maybe we say once we say communication, it may be through some sort of a network, this sort of communication is taking place, or it is in the processor itself, this sort of a communication is taking place. Now, there can be some this sort of a communication, maybe I have got a send, let us say I go for a send. Send is I would like to send some message to some other process, that is the moment I say send P and a message, I say send a message to the process P, or we say receive Q and a message, we say receive a message from the process Q. Now, what sort of a linkages are there? There is between process P and a Q. Let us say there is some sort of a link which has to be formed. Now, what we say is these links are established automatically. We will discuss about this, and they are associated with only one process. There is a between two pair of processes. This sort of a links are made, or the links may be unidirectional, or it can be bidirectional also. That is what we say, it is some sort of a communication. This is an example of a communication, maybe we will discuss about communication detail a little later, but this is what we say example of the communication, where we have got a send and a receive two primitives through which they are sending the message or they are the receiving the message by the each of the processes there. Now, this is what also we call as the inter-process communication. This is some sort of a mechanism for a process to communicate and to synchronize their actions. The moment I say this process A has to use some variables which are available with the process B or process P variable available with the Q, then there has to be some sort of a communication between their actions. Maybe my processes are executing at a same place only, or they are executing at different places. Let us say you imagine one process in a railway reservation system is executing at Chandigarh, other process is executing at Delhi. So, this is what we have to say, think of some sort of inter-process communication mechanism through which these sort of processes can communicate. Now, this message system can be, it can be there is some sort of messages without the shared variable, or it can be there with the shared variables also. Now, if let us say if P and Q wants to communicate, what are the things they need is, first of all they must establish a connection between the two processes, and then they exchange messages or receive message from the each of the processes there. Now, how do we implement this sort of a communication link? That is again very important thing. It can be physical. What do we mean by the physical communication? That is, let us say there is some sort of a hardware bus which exists between those two processors there, or we have got a network there through which these two processes are communicating, or we have got some sort of a logical properties through which they are communicating with each other. Now, once we say we will have to have this sort of linkages between these processes, what we wanted to say is, question arises how these sort of links are established. Maybe my next lectures series will answer this sort of questions, how links are established. And once we say we are establishing some sort of a linkages, is it some physical link which is coming up there, or it is just a logical link which is coming up there, or another question comes is, can a link be associated with more than two processes? Let us say there are three processes P 1, P 2, P 3. Can I think of a link between all the three processes, or how many links can be there between each pair of communicating processes? Let us say two processes are there, they are communicating. Let us say, as I said, let us say, let me say these are two processes which are communicating. Let us say these processes A and B are the processes which are communicating. Now, how many links can be there? Is it only unique link which will be there between them, or it can be some sort of a number of links which can be there? What sort of a mechanism we have to think, so that I can build up this sort of a linkages there. Then these are the some of the question which usually comes in somebody's mind, okay, how many links will be there. Now, another thing, how much can be the size of the message. Let us say I have got a message which I wanted to transfer. What should be the size of my message? Is it a fixed size? That is, each of this message will be of 80 bytes, or this message can be of a variable size, whereby this message is of a very long length also. Then another thing, is the link unidirectional or a bidirectional? That is, both the processes can communicate, or there is one way of a communication between this sort of a processes. These are some of the things which comes into the mind once the moment we say okay, there is some sort of a linkages which we would like to form between two processes there. Now, as I said initially also, okay, there can be direct communications. What do we mean by direct communication is, let us say process P wants to send the message to process Q. What will happen? Let us say processes P writes its address, yes, this is a process P, and it will be sending some message to some other process. That is, this particular message is being sent by the process, send a message to process P, and we say receive Q and a message, we say receive a message from the process Q. Okay, one is we wanted to send the message to a process P, or another is we would like to receive a message from the process Q there. So, this is what we call as a direct communication. How is it making direct? Okay, is basically this sort of a things P and a Q. I am just referring, okay, there is a process P and a process Q between which this sort of a link is being established. Now, in case it is a direct communication, our previous questions, then my links are established automatically. As we said, how this sort of a links are established. In case of a direct communication, this sort of a link has to be established first automatically, then only this sort of a communication can take place. And this sort of a link is established between one pair of a processes. That is, let us say there is a process P and a process Q. Now, once we say okay, there is some link which is being established in this, that is, it is a direct link which is being established between these two processes there, and there is exactly one link. As I said, okay, can there be more than one link? In case it is a direct communication, there will be only one link which will be created in this sort of a processes. The link may be unidirectional, but it is both unidirectional as well as bidirectional both. So, this is what we say, okay, in case of a direct communication which we have got, let us say there are two processes P and a Q, then there will be one link which will establish automatically, and it will be between those two processes there will be only one link, and it will can be unidirectional or it can be the bidirectional link there. Another communication which is there is, we say it is a indirect communication. Now, what is the indirect communication? Let us say I have got two persons to communicate. Let us say these are the two processes which are there. Let us say this is my process P and this is my process Q, which is to communicate. One, I said, okay, there can be a direct communication whereby this P sends a message to Q and Q straightaway receive this sort of a message there. Another method, now what happens is, let us say this process P is in suspended state or Q is in suspended state. In that particular case, this sort of a message cannot be transferred. Maybe that sort of a delays will be there in case we go for this sort of a scenario of a direct communication. Maybe some process which is in the sleep mode will not be able to receive or reciprocate any message there. Now, what we do in this sort of a scenario is, we go for a indirect messaging. That is, what we do is, we just make a mailbox between these two processes P and Q. That is, there are two processes P and a Q, and there is some sort of a mailbox between these two processes. What happens is, the moment P wants to send the message, he will not send it to directly to Q, this link will not be there, but he will be sending it to this mailbox and my process Q will be receiving the message from the mailbox there. What is the advantage of this? Maybe even if this process is in the suspended state or it is in some other state, still the message which has to come from P will be available to him for the processing purposes. So, this is what we call as a common mailbox. This is a common mailbox which exists between these two processes P and Q here. Now, how this sort of a links are established? As I said, messages are direct and received from the mail. Now, we sometimes in terms of the languages also or the hardware also, we also refer to them as the ports. Some sort of a communication ports are there through which this sort of messages are there. Now, another aspect of this is each mailbox has a unique ID, that is between two processes. If there is a mailbox which is existing, then it will have a unique ID through which each of this process can send or receive the messages there, and processes can communicate if they share a mailbox. So, in case of a indirect communication, till the time they share a mailbox, they cannot communicate with each other. This is one of the characteristics of this. Now, again the same question comes which we posed initially, okay, what sort of links are there. Now, in this particular case, link established if processes share a common mailbox. This is the one of the characteristics in this particular case. Okay, mailbox has to be there in case some sort of a link is to be established, and in this particular case a link may be associated with many processes, because it is quite possible many processes may be sharing the same mailbox. So, this can be between various processes, and each pair of processes may share several communication links. Okay, there may be number of communication links which may be existing there. It is through them that this sort of a link can be established, and in this particular direct case also it can be a unidirectional or a bidirectional link which can be there in this particular case. Now, what sort of operations are there in case of indirect communications? First of all, we have to create a new mailbox in case two processes are to communicate, and we send and receive message through the mailbox, and the moment my communication is over, I will be destroying that sort of a mailbox there. Now, how do I send and receive the message in this particular case? Now, we say send a message A and a message. What is the A? A is the mailbox which we have got. Now, how do my user knows whether it is for him or for somebody else? Because this is messages, mailbox has been created between two processes, they will be the ones who will be sharing this sort of a messages there. So, it is basically receive A and a message. Okay, I may be sending a message to a mailbox or I am receiving a message from the mailbox. These are the two basic primitives based on which this sort of a communication can take place. So, in case of a direct communication, it is the link which has to be established between two processes, whereas in case of a indirect communication, it is a mailbox which has to be created between two processes there, and it is through the mailbox this sort of a messages can be transferred. Now, in case of a direct communication, the moment there is no communication required, this link goes automatically, whereas in this case we have to destroy that mailbox, only then this particular thing will be destroyed. Now, in case of a mailbox, there can be other problems. Let us say there are three processes P1, P2, P3, they are sharing the mailbox. Now, let us say P1 sends a message, this message is for whom? Whether it is for P2 or it is P3, whether this message is for P2 or P3, who should get this sort of a message? Now, what sort of solution is there? We allow a link to be associated with at most two processes, and we just allow only one process to execute at one time. We may not allow all the processes to execute at the same time and allow the system to select arbitrarily the receiver, and sender is notified who has received this sort of a message there. Let us say the process P 2 was to receive this message. In case P 3 has received the message, message will go to the P 1, that P 3 has received this sort of a message there. In case it is P 3 who is not to receive this sort of a message, again this sort of information will be going to him. So, this is what we have got in case of indirect communication. Now, my message passing may be either blocking or non-blocking. Blocking is synchronized. The moment there is a message which is blocked, we say it is a synchronized message, and non-blocking is considered as a asynchronized message there. Now, my send or a receive, these primitives can be either blocking or it can be the non-blocking primitives there. Now, let us say there are a number of messages in case it is going from process P to the other process. What will happen to the message which has not been received? Now, what we do in this sort of cases is there is a solution which we call as a buffering. Now, what is a buffering? Let us say two processes want to communicate. What we do is we try to keep some sort of a buffer between them till the time the message is received by the receiver, it will be kept in the buffer there. Now, my buffer can be a zero capacity. What do we mean by zero capacity is? That is, the moment a message goes from the sender, it has to be received by the receiver. There is no intermediate mechanism through which it can be put it at the buffer there, or it is a bounded capacity. Let us say we just define okay, this is the length of the n messages which can be kept in the buffer. So, what will happen? See, only those n messages will be kept in the buffer, it can be received at a later stage, but in case my buffer is full, then I cannot add more messages to the buffer there, or it can be unbounded capacity. What do we mean by unbounded capacity is? There can be infinite length for the messages. So, this is how my buffer will look like. Let us say I have got process P and a process Q. Now, in case it is a zero capacity buffer, that means it is a straight away going from here to here. So, this is what we call as a zero capacity. There is the moment P wants to send a message to Q, till the time it receives, it cannot send any other message there. Now, or it can be between P and a Q. Let us say this is my buffer, and let us say this is a buffer of only 3 messages. So, this is what we call as a bounded buffer. That is, the message, number of messages which a process can send as fixed. In case I want this process P sends more messages than this will go into the, it will not be put into the buffer, and it will be like this. Okay, that is, between P and a Q, there is a buffer of a message there, where we can put the number of messages there. This is what we call the boundary buffer, or it can be just a buffer which is a infinite. What do we mean by infinite buffer? That is, the moment I wanted to store certain messages into the buffer, the size of this will increase. That is, size of this particular buffer increases. It can be some sort of a dynamic storages which are there, maybe a linked list can be one of the examples for the unbound buffer. The moment there is some message which is to be stored, there is some link which is created and memory is allocated there, and this is how this is linked to this. So, this is what we have got unbound buffer. So, in case of a unbounded buffer, there can be any number of messages which can be there stored into the buffer there, whereas in this particular case there can be fixed number of messages which can be there, and in this particular case there is only one message which can be going from the P to the Q there. This is the concept of the buffering which we have got. Now, it can be other type of communication, maybe once we go for distributed operating system, there will go through this sort of a communications also. We say it is a client server communication, that is I have got a server machine, I have got a client machines. Now, it can be through sockets, we can do this sort of a work, or it can be through the RPCs, we call it as a remote process calls, or in case of a Java we say it is a remote method invocation. Now, it is related to socket programming or RPCs, or it is a RMIs. Maybe these are the part of the languages, maybe in case of a Java we use it, in case of a Linux we make use of this RPCs. Now, what do we mean by socket? Now, this is what we say in the layman's term, we say it is a endpoint of the communication. Okay, it is at this particular point my communication will end, or sometimes we call it as a port also, or we say it is a concatenation of IP address and the port, that is what we call as a socket. Now, this in case of a operating system, this is a big topic which we say it is a socket programming. Maybe in case of those of you who are interested for the programming works, this is one of the areas of operating system where one can work, we call it as socket programming. Let us say this is a socket, this is a socket address which is there. Maybe my port is 1625 on the host, this is my host 161.25.19.8, and this is the port on which this particular communication can take place. And once there is a communication which has to take place between sockets, it has to be between two pair of sockets. Now, I will be getting the port address from where I have to receive the message, and I will get the port address to which I have to send the message there. Maybe this is a combination with the IP address. This will give me what is the machine which is sending me the message, and to which port this sort of a message has to go. This is what we call as socket programming. So, this is how my socket communication will look like. Let us say this is my host and this is my server. Let us say this is my client, this is my server. Now, this has got this particular address and this has got this particular address. Once they have to send certain messages, they have to send it to the port. Let me say this is my port address and this is my other port address which is there. So, this is what we call as the socket communication. Or another we have got is a remote procedure calls. What happens is, let us say I have got a procedure which is executed on some other machines, that we call, we have to execute it as a remote procedure call. That is, we are executing some procedure between two processes, that is on the network system. That is, we have got a network system, we have got a big application which we would like to execute. One is whole of this application I execute on the same system there, or another is I make it as a small procedures and execute this application on a number of machines there. So, what will happen in this particular case? Now, once I have to invoke some of the procedure, we have to go for the remote procedure call, because let us say server has to revoke these calls. It is through this remote procedure call, this sort of things can be there, and we just define some sort of a stubs. Stubs is some sort of a proxy which will be there on a client side, whereas this is executed at some other side. Maybe this procedure is executed on the client side or server side, but we write it as a stub there, and the client side stub locates the server and marshals the parameters there. That is, whatever parameter has to be passed, that are being passed by the client machine to the server machine, and the server side receive the stub, receive this message, unpack the marshal parameters and perform the procedure on the server. That is, what happens is, the moment my my client machine sends a stub, what does the stub contain? That contains all sort of variables which are there in case of this sort of a process. So, whatever, now as I say, this particular procedure has to execute on the server side. Now, the moment we say it has to execute on the server side, so all the variables has to be passed to the server side there. Now, all the variables are passed to the server side, then what happens is my from the message I unpack the parameters and perform the procedure on the server there. So, this is what we call as a remote procedure call, or now this is how my procedure gets executed on a client and a server machines. Let us say this is my client, this is my message, and this is the server which we have got. Let us say my client user calls a kernel to send RPC message to the procedure X, that is there is a procedure X to which some RPC call has to be sent. Now, this since each of this client as well as server will have got its own kernels there. So, it sends it to the kernel, and kernel sends a message to the matchmaker to find port number, because basically we have to find the port number on which we have to send this sort of a message there. So, this is the message which will constituted from, to, port and the regarding, and at my server if the message is received and look up the answer there, okay, what sort of a answer is there, and this matchmaker replies to the client with the port P. It gives okay, this is a this particular machine is at this particular port P, and this sort of a message is again sent to the message. Now, you will observe okay, in case of a client to the server communication, it is from client to the server, whereas now it changed to from server to client, and it gives the port P. And now, what is happening? My kernel places port P in the user RPC message. Whatever my user RPC message was there, I will be placing this particular values there, the value of this particular port, and now kernel send the message. Kernel sends RPC, that is whatever remote procedure call which is there. Now, initially we did not know about the port to which it has to be sent. Now, once I got this sort of information, this sends to the message. Again it is from client to server and port P, that is for this particular port, this is the contents of the message there, and now we listen to the port P, okay, what sort of a message has come to the server at from this particular port, and my process whatever request is there, that is processed and send the output to the client, and that is again sent through the message only, again from RPC to port P to client and port to the kernel. That is port is sending this sort of information to the kernel, and kernel will receive this information and repasses this reply to the user. Now, this is how my client server computing can take place. Now, all this computing takes place through the messages. A client sends the message to the kernel, kernel finds the port from the server, and then it combines it with the message. Okay, for this particular port, this is the message which has to go, and server processes that message and then sends the reply back over there. This is how this sort of a communication takes place. Or it is the remote method invocation. We are in case of a Java, this is very specific thing, we call them as the RMA calls. Now, it is similar to your RPCs, the way remote process calls are executed in case of a Linux or a Unix machines. The same way on a Java platform, RMIs are executed, and RMI allows a Java program on one machine to invoke a method on the remote object. This is very interesting in this particular language Java. What happens is, maybe I have got one application where I have got one call which has to execute on the server. I can invoke my RMI, through my RMI I will be executing that particular object there. Let us say this is what we have got, my Java program is here, and there is remote method invocation which is there, and this particular thing gets executed at this particular place here. So, this is what we call as a remote method invocation, which is another way through which I can execute a procedure by making use of the Java calls. Now, how does this parameters are marshaled? As I said, there is a parameter marshalling which has to take place either through Java or the RMI calls. Now, what happens is on the client side or on the remote object side, there is a stub. What is the stub? Stub got all sort of a parameter which has to be passed to the object for the execution purpose. That is, there is some method A, B are the values which are there, and there is some method which is to be passed to this particular skeleton procedure which is to be executed over there. Now, once we say okay, my processes are executing in a cooperative mode, what I have to do? I must be able to synchronize them. Why do we need a synchronization? Let us say I got this this example. Let us say what I wanted to do is there is a process A, process B. I explained this example in the earlier sessions also. Let us say it says A x is equal to 0, it says x is equal to 1. What does it mean? Both these procedures A and B, they are using the same variables, and it says x is equal to x plus 1, it says x is equal to x multiplied by 2, and we say print x and we say print x. Now, the moment it says x is equal to 0, x is equal to x plus 1 and print x, both, let us say both these processes A and the process B, they are executing in a concurrent mode. What does we mean by concurrent mode? They are executing simultaneously. Now, let us say you assume okay, there is no synchronization between these two processes. Let us say this process execute like this, initially x is 0, then x is 1, then this particular statement, then this statement, then this statement, and then this statement. Maybe this is one sort of a execution which I am telling you. The moment x is 0, the x will be assigned the value 0 there. The moment it goes to this particular statement, x becomes 1. Now, what has happened? Now, the moment next statement x is equal to x plus 1 is executed, the value of x for this particular procedure will become 2, and the moment it comes over here, it says x is equal to extra 2, it will make x is equal to 4. Now, the moment it says print x, it will print 4 and it will print 4 over here. Now, what has happened? There is some sort of a problem which has arisen in by this sort of a execution in my results, whereas actually the result should be x is equal to 0, x is x plus 1, 1 and print x. It should have printed 1 here, and in this particular case it should have printed 2 over here, whereas in both the cases it is printing 4. Why this sort of a thing has happened? We have got two procedures A and a B which are to be executed, and we are trying to execute them in the synchronized mode, because since we have not performed any synchronization, that is why this sort of problem is arising. Now, that is what we call as the process synchronization. In case two processes are to execute in a cooperative mode, or they are to share some of the things of between themselves, then what we have to do is we have to think about process synchronization there. That is, concurrent access to shared data may result in a data inconsistency. This is what I tried to show you. Okay, this sort of a things can give you some sort of a inconsistency in the data there. What sort of inconsistency there? The printed value should have been 1 or 2, and it is giving you 4 for each of the case. Now, what we require is, we require some sort of a mechanism through which we can think about the orderly execution of the cooperative processes. We have talked about the cooperative processes, but another thing which is required is we have to think about some mechanism through which these processes can execute in a cooperative way. Now, what sort of things we have to do? Let us say I have got a shared memory solution to a bounded buffer problem. We at most n minus items in a buffer at the same time. Now, what happens is a solution where all n buffers are used is not very simple. Okay, let us say there are n minus 1 buffers which are there. How exactly I can synchronize this sort of buffers? Now, there is a very famous problem which we say is a producer consumer problem, that is where cooperative processes comes into the picture. Let us say if I have got a process A and process B. Now, let us say process A is a producer and this process B is a consumer. right. Now, how can we correlate? Let us say this particular process A is producing some things. Now, it cannot produce more till the time this particular thing is consumed by the consumer. Now, let us say you assume in case of our daily lives, let us say we keep on producing things and it is not consumed. Let us say you keep on producing two wheelers, but there is no consumer for the two wheelers. What will happen? Maybe you will have a dead stocks here at A, and sooner or later the company who is producing this sort of thing will die. Or you assume another thing, okay, I wanted to consume certain things, but my producer is not producing that sort of things. What will happen? I will not be able to consume that sort of things there. Now, this is what happens in case of some of these processes there. Now, what will be the solution there? Let us say there is a producer, there is a consumer. It can't be okay, whatever is produced by him is consumed by at the same time. Maybe my consumers are slow, producers are fast. What we do is we think of some sort of a buffers. Now, what happens in this particular scenario is, let us say producer is producing certain things, it goes to the buffer, and from buffer B is consuming. Now, printer and a computer is a very good example of this. Now, what happens is my computer must be producing printout output data at a very faster pace. My printer may be slow. Now, what happens in this particular scenario? My computer becomes the producer and printer becomes the consumer over here. Maybe my computer or my CPU. Because why it is this so? Because CPU processes the data at a very faster pace, whereas my consumer, which is printer, is not able to print the same character at the same time. Now, what happens is, for this particular computers, what we do is we just go for a buffer. You might have seen each of these printer has got its own buffers. Now, what happens is the moment it is output is produced by A, it goes to this, and from here it is consumed by the producer there. This is what we call as a consumer and a producer problem. Now, it can be quite possible my buffer is 0. Let us say you assume in case of my printer and a computer, there is no buffer in between. Maybe half of the data which is to be produced, which is to be printed, will not be printed at all, or my CPU will not work at the maximized speed over there. Now, what we do is in this particular scenario only, suppose we modify the producer consumer problem by adding a variable counter, and we initialize it to 0 and increment each time a new item is added to the buffer. Okay, that is what we do is the moment how do we take care of the consumer and producer? We just add a variable which we say it is a increment. We increment the moment any item is added to this, and we decrement the moment it is consumed by the consumer there. Maybe this is what my bounded buffer will look like. Okay, what will I have is I will have some sort of a buffer there. Let us say this buffer is a bounded buffer, it is of fixed size, and I have got a counter. What is my counter doing? The moment I add one item to this, it will increment it. The moment it is consumed, it will be made 0. So, this is how my producer process will look like. Okay, I will keep on adding one to this. The moment my buffer is added, I add one to the buffer and I add one to the counter there. And the moment it is consumed, I will be decrementing my counter here. That is, this particular item has been consumed there. So, this is how the process of a consumer and a producer will continue. What we have got is we have got a bound buffer. What are the characteristics of this bound buffer? It will take fixed amount of items as far as my buffers is concerned. Now, the another aspect comes is the counter plus plus and counter minus minus, they must be performed atomically, meaning thereby the moment I have added 1 to the buffer, it must be added to the buffer. The moment I had decremented 1, it must be decremented from the buffer. Atomicity is this whole statement must be executed at the same time there. Because I gave you the example how this thing can happen. Let us say this statement count plus plus, how does get implemented in case of a system is I just put a register 1 and say counter, and register 1 is equal to register 1 plus 1 and counter is equal to register. This is how this sort of a statement is executed, and this is the way my count minus minus is executed. Now, let us say you assume that only one statement is executed, then this particular statement start executing. Then what will happen? Maybe there will be some sort of a wrong results which will be coming there. I will give you the example. Let us see if both producer and consumer attempt to update the buffer concurrently. I have given you the example how this sort of a buffers are getting incremented or decremented. Now, you assume both of them start incrementing and decrementing at the same time, because my buffer is same, obviously this sort of a register will be same. So, it will can give you some sort of a wrong results, or it will say interleaving depends upon how the producer and the consumer processor are scheduled. Now, this is how it will look like. Now, let us say assume we are initially having the counter as 1. One interleaving statement can be producer, it says register 1 is equal to counter, register 1 is equal to 5, and producer it says register 1 is equal to register 1 plus 1. That means, register 1, the value of register 1 will become 6, and my next consumer statement register 2 is equal to counter and register 2 is equal to 5. That means, I operate upon both the register and then I decrement this sort of a register there. Now, ultimately what will happen? The value of the count may be either 4 or 6, whereas this particular value should have been 5. So, this is what happens in case my producer and the consumer variables are get interleaved. Okay, that is, this is what we call as the problem of the atomicity. Okay, I may be having some operations which I would like to have them as a single operation over here, but this may lead us to some sort of problems there. Now, this is what also we call as a race condition. Race condition is both the processes are trying to update a variable. If I do not define anything of this sort, we say okay, any of them, the moment any of them has the access, he will be able to update this particular value. This sort of a situation we call them as a race condition. The final value of the shared data depends upon which process finishes the last. Now, what we have to do is okay, to prevent this sort of a race condition, we have to think about some sort of a synchronization. I hope you might have understood this sort of problem of the cooperative processes, which once process has to execute in a cooperative mode, they end up with some sort of a race condition. How we can take care of them? We must execute them in a synchronized way, and we call that as a critical section problem also. Now, there may be n processes all competing to use some shared data over there. Now, we say each of this process has got some segment which is critical to this critical to the other processes. Now, what we do is we ensure that one process is in critical section, the other process should not get into the critical section. The way I gave you this process A and a B, let us say this process A and the process B, let us say it has got some statements, and afterward it says x is equal to 0, x is equal to 1, x is equal to x plus 1, x is equal to x star 2, and we say print x, and afterwards again there are few statements which are there. Now, let us say these are the statements which are independent, and these are the statements where shared variables are being used. So, what we do is this sort of a area we say this is the critical section. This is the critical section for this particular problem, and once a critical section has to execute, what we have to do is we have to make sure the moment a process has entered into critical section, there is no other process which is in the cooperative fashion to execute in the critical section. Meaning thereby the moment process A has started executing statement from here, we allow him to continue with this up to this particular statement. So, this is what we call as the critical section problem, and this is the solution for this. Okay, maybe in case there are more than one processes which are in the critical section, I allow only one process to execute in the critical sections there. I hope this is what we say is a critical section, and this is what we say is a critical section solution. Maybe there are semaphores through which this problem is solved, or there is a simple method through which we say only one job will enter into the critical sections there. Now, these are some of the solutions to the critical sections. We say is a mutual exclusion. Okay, if process P I executing in its critical section, then no other process can be executed in their critical section. This is what I had tried to show you. Okay, in case one process has entered into the critical section, the process A has entered into the critical section, I will not allow process B to enter into the critical section there and execute. And another is the progress. Okay, that is, if no process is executed in the critical section and there is another process which wants to enter into the critical section, then I cannot postpone this decision of this particular process entering into the critical section indefinitely. That means, I have to take the decision okay, this process will get into the critical section in case there is no process which is executing in the critical sections there. Now, then we have got a bounded wait. Okay, it is not that one process keeps on waiting for him to enter into the critical section. We say there must be bounded wait, number of times the other process are allowed to enter the critical section after a process has made the request to enter into the critical section, because it can't be unbounded thing whereby I keep on waiting for to enter into the critical section. There must be some sort of a bound. Okay, the moment I request, the moment this sort of a thing is there. Now, what we assume in this particular case for the solution to the critical section is they operate at a non-zero speed, and there is a relative speed of the n processes there. There is no process which will execute at 0 speed. What does it we mean by 0 speed is? That means, the process does not execute. So, this is what we have got as a solution for the critical sections. Now, this is once we say we are going for the solution for the critical section, we say there are so many methods through which I do it. Maybe I think of some sort of hardware through which I can implement this sort of a solution. Maybe there is a flag there through which I can implement this, or there can be a boolean variable through which I can implement. Okay, let us say there are 5 jobs which are to enter into the critical section. I flag one of the job, it is in the critical section, rest of the jobs can be not there in the critical section, or I can think of a semaphores. Semaphore is again a method through which I assign a value. Okay, this is in the critical section, this is not in the critical sections there. So, this is what we have done today. Okay, we have discussed about the critical section problem, critical cooperative processes, what sort of processes are in the cooperative way. Okay, 2 processes which share the variables, we say they are in the critical section. Now, once they are in the critical cooperative processes, then it is quite possible they may be sharing some sort of information through them. It can be direct communication through which they can work, or it can be indirect communication through which it can work. Now, this can lead us to a problem where in case there are 2 processes which share the variables, then in that case what happens is, in case I do not synchronize them, there can be the problem of inconsistencies in the results. So, how do we solve this? We say this problem is of the critical section. How do we solve it? Okay, in case my process has to enter into a critical section, I will allow only one process to enter into the critical section there. So, this is all about what we have got in case of the cooperative processes. Thank you very much.